Oh, finally, it's working. Okay, I'm going to go and share this link on the Facebook page. So just bear with me a minute, please. Yeah, okay, I finally got it working. It's taken me about an hour to get the camera to attach to the stream, so I'm sorry about that, guys. Okay, so what I'm going to do is every day I get asked the same question all the time, and people want to know, quite rightly, about filters and how they work on the SP-2400, how they work compared to the original machine. And of course, a lot of people have their own opinions on how my machine works, which can often cause a bit of confusion amongst people. So I want to try and set the record straight with what's going on. And this video is an attempt to do that. So this is just a board, a machine that I've been using for testing form and fit and stuff in the past. So that's why a lot of the components aren't even on this board, but it will suffice enough for me to sort of give this explanation of what's going on. So the original machine, when people talk about analog filters, there are several different kinds of filters in the original. And so what they were was an input filter. And what the input filter did was basically prepare the signal before it hits the ADC. Now, in my opinion, that input filter, it was an anti-aliasing filter. That input filter has quite an impact on the sound, and I'll come back to that. Then on the original, there were also then another 6 filters on the outputs. 4 of those were fixed equalization filters, and 2 of those were what they called dynamic filters, which included 2 SSM 2044 chips. Again, I'll come back to that. So let's start off with the input filtration. And on the original, there was what's called an anti-aliasing filter. And what that did is basically attempt to cut off any frequency content that was around about above 13.02 kilohertz. Now, for the astute among you that know a bit about sampling and DSP and stuff like that, 13.02 kilohertz was the Nyquist frequency, which is half the frequency of the original sampling rate, which was, I think, 26.040 kilohertz. Some people think it's 27, some people think it's 26.040, and I believe there might have been some differences between the SP-12 and the SP-1200. They're reasonably negligible anyway. And so what that's doing is that input analog input filter for anti-aliasing is preparing the signal before it hits the ADC. That part of the analog input filtration circuitry is exactly the same on the SP-2400, and that resides in this area here on the board. The difference being on the SP-2400 is just that we've got 2 of them. We've got 2 of them for the necessity of doing stereo sampling. So you're hitting two anti-aliasing filters for your left and your right channel. Exactly the same circuitry, it's just that we've got 2 of them. So after we've hit that, also what I should actually talk about as well while I'm talking about the input anti-aliasing filter is that something to bear in mind is with the SP-2400, you can bang an SD card in there that's just got tons of samples on it, and those samples might be stereo, they might be 48 kilohertz, they might be you know, they get 44.1. All sorts of stuff could be going on with the samples that you've put on your card in the machine. And although you will still be hitting the internal pitching algorithm, which in its own brings in lots of nice artifacts and stuff like that, you won't have recorded those samples in through the input filter, which I think is quite important to the characteristics of the sound that you're sampling. So how have I dealt with that with the SP-2400? Is that we've got some digital logic here which switches the analog signals that are coming in and out of the SP-2400. And so what you can do is you can take your sample that you've dumped on an SD card and say, hey, resample this. And what that will do is will give you the analog output from the DAC for the sample that's being played from your card, and it will reroute the signal through the internal analog input filter. Essentially what that's the same as doing is plugging a jack into your output and then rerouting it back to your sample input and recording the result. So that's one thing that we've covered there, so that you'll be able to resample your existing samples on the card and run them through as if you had actually sampled them into the SP-2400 directly into the inputs, which of course you can also do. Okay, so that covers that, and that covers you getting that original, you know, crunchy sound as it should sound. Now what I'm going to talk about real quickly is the output filters. And as I said, on the original, there were 6 of those. 4 of them are 4 of those are fixed output equalization filters, I should say. And those are fixed analog filters by definition. They're not sweepable, and they're not sweepable on the original. The only difference between mine and the ones on the original is that the output was split between the tip and the ring on the jack outputs on the original. And so and I believe what those fixed filters were really is to give you a real quick start, roughly good sounding mix. If you followed, you know, putting your kick here and then your bass here, I think what those fixed filters did was just give you a sort of a roughly good sounding mix already. But of course there was the old trick of pulling the jack slightly out of the socket, which would give you the filtered signal or the unfiltered signal. So you could go direct, or you could use the analog fixed frequency analog filters. On the SP-2400, again, we've got some digitally controlled logic chips here for routing the analog signals. And so essentially, when you've got a jack plugged into there, under software control or under the control of the firmware in the SP-2400, you can decide to actually bring, these are the fixed frequency analog filters here. You can decide to bring them in or out of circuit so that you don't need to plug the jack in and out. So that's the fixed frequency filters dealt with. And again, as I said, they're the same circuitry, same schematic, works the same, sounds the same. And then there were also 2 what they called dynamic filters, which used the SSM-2044 chip. Now, SSM are no longer in business, but the same guys behind SSM recently, I think last year or the year before, started up again. And luckily for us all, they re-released the original SSM-2044 as the SSI 2144. Originally, I believe they probably had to change the name because originally SSM got bought out by Analog Devices, which is why you see a lot of Analog Devices audio stuff still starts with the SSM prefix. Anyway, that's a boring history lesson. The SSI 2144 filters, I believe, are essentially the same dies. They've just been shrunk and maybe had some improvements for thermal, maybe, and current handling. But to all intents and purposes, you should be able to see loads of comparison videos and stuff on those filters. They sound the same as far as I'm concerned. Again, my board here with the schematic is exactly the same. There are some modifications that people have done to their 1200s where you can change the cutoff and resonance and stuff, but they're not included on this board. This board stays faithful to the original. As far as I can tell, really, the dynamic filters weren't actually really being used as filters per se. I think they were used to control decay of sound. So let's say you had like a long cymbal or something like that. what the control would do, it was just a digital control that would discharge a capacitor on these original SSM filters, and what it would essentially do is really quickly turn the cutoff down to go, which would have the effect of changing the envelope, decay envelope of the sound. And you could adjust those with these two trim pots, which again, it's exactly the same on the SP-2400. So that all of the analog input and output filtration remains analog and remains faithful. Now, in addition to being the same as the original in that respect, what we've also got is digital DSP-based filters for both high pass and low pass, which I believe are based upon the like Moog ladder sort of topology. And there's probably going to be scope for us to be able to do different filter responses and stuff in DSP to give you different flavors of filters. That's not a problem. And there are 8 of those on each voice, and of course they are sweepable, cut off, and resonance. Now, on the SP-2400, what I've also done here, you can see in this unpopulated header here, is broken out all of the analog output signals into this header, along with some control lines for microprocessor control, so that we can release an 8-channel sweepable, voltage controllable, sweepable filters. So we can have 8 of these SSI-2144 all on there, intercepting each voice, and they will be under software control. So you'll still be using the top panel controls, but they're going into another separate DAC, which is then voltage controlling those SSI-2144 chips. Now, a couple of reasons why I did that as a daughter board. One of them is it keeps the initial build cost of the machine down. Believe it or not everyone wants analog filters. It doesn't interest everybody, but I know it does interest some people, including myself. So they're there if people want them. Also, if they're built onto a daughter card, we're not stuck with just SSI-2144 filters. Loads of different chips are now, luckily for us, back in manufacture. Curtis has re-released their filters. There's also clones of Curtis filters, and you know, there's loads of different filter designs to choose from. So if we're on a separate daughter card, we can release different flavors of filter cards. Also, I think the likelihood is that we will make available to some level the schematics or the board, the pinout layout and everything, so, and the dimensions, so that third parties can make their own filter daughter cards. And also, this doesn't actually have to just be a filter daughter card. You know, you could have DSP effects on there. There's lots of hobbyist DSP chips and stuff like that. So we're going to work towards releasing some sort of kit, I guess, not a physical kit, but you know, there would be some level of software development involved, and also you'd be making your own PCB if you wanted to make daughter cards. I think that just about wraps up everything that I needed to say about filters, just to set the record straight with everyone. Howdy, what's up, Brad? Hey guys, wow, what's a treat live stream? I'm just looking at the questions really, just real quickly, just to see if there's anything in here. I'm trying to use my potato filter. Whatever, dude. Stereo thread is sexy, yes, of course. Wow, that rerouting off SD is impressive. Thanks, Chip Haynes. What a name. Will you be able to adjust gain during resample? Yes, we will be able to adjust gain during resample. Impressive, can't spell. Yep. Well done, Brad. Okay, well, thank you very much for listening. I think that covers everything about the filters. So just to reiterate, the analog filters for both input and output are exactly the same and stay faithful to the original, with the added inclusion of digital filters that are already in the unit when it ships, and further down the line, the daughter card expansion is made available for people. No adjusting pitch during resample, because it will, when you hit resample button, the machine is going to lock out, really. As far as I can see that working, the machine will lock out because it's going to reroute all the outputs, so there wouldn't be coming anything out the outputs that you'd hear. It'd be internally rerouted, hitting the input filter again and going straight back into the ADC. So so I think that covers everything. I'm going to end the stream here, and thanks for listening. Bye.